Okay, so I thought I'd share this little project with you. I consider this to be one of my proudest failures, if you want to call it that. Basically, okay, to explain what this is, what you're looking at, um, it, well, okay, it looks a little bit weird. Okay, it has a story. So, first of all, um, this is supposed to be a mixing unit, a magnetic mixing unit. Now it's battery operated specifically. Now you can purchase them online, and specifically you can purchase quite a lot of um, uh, non-battery operated ones. But from our side, we had a client that specifically wanted to do mixing of material within a vacuum chamber, specifically to mix water and oil within a vacuum chamber. So anyway, so as a little pet project, we thought we'll try to build a device for them, and this is the result. Okay, so there's a couple of things that went right with this, and obviously there's a couple of things that went wrong. If you look really closely, you'll see this used to be a perfectly square and non-warped piece of material, and after being used in a vacuum chamber for only a couple of times, it is extremely warped. So the basic principle of this is you'll place your material, or the bowl of material with liquid on top here that you want mixed, and then you'll have a remote control to set the speed, and just below this all you have is essentially a set of magnets. At that point this was still experimental, so I left a couple of extra holes in there for to test how many magnets would work best and so forth. So as it turns out, this was our best arrangement. I guess it would actually be better to just put it straight in the center and have a really strong one in the center. But anyway, so that's where the first failure came in. The motor that I chose was way too slow. So at maximum RPM I think it's 600 RPMs, and that's not enough to make it spin. It has a nice lot of torque, but it's not able to make a nice little whirlpool in the liquid that needs to spin. So it's yeah, sure, okay, that's just the design flaw overview. Oversight. You didn't have much time. I can always just place a new motor in here. I'll just open that up for you to see. So only thing that's in there is Arduino Nano in there, and a small little motor driver, and basically a voltage rail, and then we've got the display, um, uh, well, 7-segment display module, and then this is where my pride and joy actually comes in, and I'll explain what that is. So essentially, if you look closely at that, I'll try to get it into the light. So what you're looking at in there is one of the standard and commonly available infrared remote sensors. So one big problem with those modules is that they can only, you've got a very limited range, let's say at an angle of let's say 45 degrees or even less, that you can detect. If the remote control is pressed on the side, you can only detect it from front. So here the key thing was we made a mold and used polyester to cast this. Now this was designed, this shape was designed in Fusion 360 to be just slightly bigger than the module itself, and then we made a mold out of that and then cast it polyester, and then what this allows is a 360 degree sensor. So instead of just picking up 45 degrees, we can now use a remote control from the top, because when this is in the vacuum chamber, you cannot use it. you know, you can't always have your hand in the front of the thing. You need to work from the top or possibly from the side and so forth. So yes, this provided a 360-degree angle, and this device worked pretty great until, well, we realized how much it's getting warped inside. And okay, at the bottom it's just battery operated, simple. We didn't choose lithium batteries, just AAA batteries, but we've gone lithium batteries in, you know, if I had to redesign this. And but yeah, that's just the basic story of this little guy. So it used to run perfectly, and now it still runs now, but obviously it's not, you know, not even that surface is flat at the top anymore. You know, everything, there's a nice angle. As you can see, it's warped everywhere just due to being in a vacuum chamber. So yeah, that's the results of what you get when you basically place PLA printed material into a vacuum chamber. In any case, I just thought I'd share that little story with you. For anybody else who wants to work with PLA and a vacuum chamber, and for anybody who might have a use for that type of approach where you need a 360-degree angle within a vacuum chamber.